Quarterly means 4 times a year. Quarters, right? How many quarters make $1? So 4 times a year. And then how many years? Is 25. And then you type it in your calculator. So if you did it correctly, you should get 18,111 and 62 cents. Make sure you put parentheses when you go 4 times 25. All right, can you try 2B? Daily. How will that change if it's daily? 300 and how many? Did you say 65? Well, if it was a leap year, then what number would you use? It's a good question. So, the question would be again, which one do you think would give you the greater amount between the two? And daily, the more times you compound the interest, the more money would be in the account, right? So, change it. You've already done the work of typing it in. Just change the 4 to 365. And then, how much is now in the account? 18,000. I would think to you, $300 and some is like a big amount. I think it's a big amount. If I gave you a choice between the two, which one would you take? All right, number 3 is all about Amelia. Here we go. When Amelia turned 6, how many years ago did you turn 6?
Too many.
All right. Her grandparents opened up a college savings account for her and put in $500 in the college savings account. The account earns 3.2% interest compounded bi-monthly. Bi-monthly means twice a month. Like semi-annually, twice a year. Bi-monthly means twice a month. If, like, bi means 2. So if her grandparents make no other deposits or withdrawals, how much money will be in the account when Amelia reaches 18? All right, you set it up, and then I'll set it up. You want this to be like $50,000, but it won't. It'll be enough for like 3 textbooks for Amelia. So the first trick is, do you know how to change 3.2% to a decimal? Are you comfortable with 0.032? Next, compounded bi-monthly. I just told you that means twice a month. For a whole year, how much is that? So can you see where 24 comes from? 12 months a year, twice a year, 2 times a month, right? 2 times 12. And then the last part is, how many years? Well, 6 to 18 is how many years? She's 6 and then 18. Obviously, 18 take away 6 is 12. Use your calculator. So again, you'd hope it would pay for tuition for a year, but it clearly doesn't. $742. They should have bought her a Disney pass instead for the year. Oh, you know what I did wrong? I'm not a good banker. Yeah, it should be 0.032. 701 decimal place. $733.88. So as I said, that's about one annual pass to Disneyland. Save up. Here we go. Turn the page. All right, read number 4. Annotate it and set it up. As I said, if you want to remember a formula, practice using it and you'll remember it. Don't put it on an index card and just try to flippy and think that's going to be the best way to memorize it, right? How you memorize something is by using it and then you remember it. So number 4. All right, did everyone get a chance to set it up, put it in their calculator, get an answer, and know they did it right, and I'll do it? You say, hold on, I'm not even sitting down yet. Did you notice a difference in what's being asked? Were you careful to be a good reader? Do you see it? Do you see that they're asking for something a little different? Because you're being a good reader, right? Now, I'm going to start it the same way. Notice they're not asking how much will be in the account. Instead, what are they asking? How much interest there is. Now, we're still going to do what we've been doing, but there's an extra step at the end to figure out just interest. So, I'm still going to start here. She opens up with $750, 1 plus. Now, be careful here. 0.4%. 0.004. Did you do that right? You really have to move that decimal place. Compounded how often? Semi-annually means how many times a year? Write it down twice. And then how many years? All right, so first calculate it. And if you did it correctly, you got $780 and... Now, the question did not ask how much is in the account. Instead, it asks how much interest. So, what did we end with? What did we start with? And if I subtract them, what's left over is just the interest. So over 10 years, the interest was $30.58 in interest only. All right, try number 5. And yes, I'm very intrigued how you're going to write 2 3/8 as a decimal. And again, be a good reader. Are they asking for just the interest, or are they asking for what will be in the account? Whatever they're asking. Right there. Well, not, I mean, you gotta make it. Or did you just not want to get up and get that part? Like, I just don't have the energy for that.
I made it to an impossible fraction.
All right, did you have a chance? Number 5? So, did you come through? 2 3/8%. Did you come through? Now, because you have a calculator in front of you, it can't really be that much easier, right? You can go 3 divided by 8 if you don't know what the decimal is of that fraction. So, we're starting with $1,000. We're going to go 1 plus. Now, I just got to figure out 2 3/8 is the same as 2 point what? I'm just going to put in the fraction, 3 divided by 8. So, if you didn't have a calculator, you would divide. So, 0.375, did you get that? So if you didn't have a calculator, you'd actually go, this is what would give you the answer. Yes? I know you could do that if you were motivated enough to do it. But you have a calculator, right? You get 0.375. All right. So it's, move the decimal. So it's 0.02375. Hey, could you round there? No. Bankers don't do that. Every number matters, especially as the numbers get bigger and bigger and bigger and bigger and so on. So every number matters. And you divide it by, it's compounded how often? How many times a year is quarterly? And then how many years? So it doesn't tell us, but we started in what year? And we ended in what year? So can you just think through how many years that is? All right. Let's use your calculator now. And you get $2,290.55. Did you get that on your own? Now, there's a second formula we're going to use. And the second formula is, what happens if you compound continuously? Now, what does that mean? It means every time you calculate interest and add it back in, you just do it over and over and over again until you die, right? It's that forever action of doing it over and over and over again. You don't do it once a year, twice a year, 10 times a year. You're doing it all the time. Every moment is doing that calculating. Which one do you think will give us more money in our account? Compounding continuously, or monthly or daily or quarterly and so on, right? So the more often we compound, the more money will be in the account. All right, so we have a formula for that, and it follows the formula that we used yesterday for it. Do you remember the cheap shampoo I said? So A equals P times E to the RT. We used it yesterday for continuous growth. In this case, what's growing continuously is money compared to yesterday. So, suppose $800 is invested in an account at 6% interest rate compounded continuously. And that's the key word to know you're using PERT is the word continuously. If no other withdrawals or deposits are made, find the balance. That's what we're looking for in the account after 20 years. So we start with, how much money do we start with? And then we don't go 1 plus. Instead, we use E. Now, in math, E is a number and not a letter. It's about 2.7. It's in your calculator. So E, and then it's E to what exponent? Well, R, the interest rate, would be 0.06. And then how many years? And now use your calculator. So I'm going to type in 800 remember where E is in your calculator. And then 0.06 times 20. In this case, I have to close it twice. Did you type it in correctly? $2,656.09. Number 7. Find the balance of an account. That's my question. So, sometimes they'll ask you for only the interest. Sometimes you're asked for the balance of the account. What does the word balance mean in a banking sense? The word balance in a banking sense is how much is in your account. Yes? Hey, what's my balance? What are you asking for? How much is in your account? Balance could mean like, are you going to fall over or do you have your balance, right? That's like two different meanings. All right, after how many years? What is the principal amount? $1,200. What's the interest rate? 12.5% per year, and then it's compounded continuously. So when I see compounded continuously, what's the formula? I'm starting with 1,200, and then the interest rate as a decimal would be 0.125, and then how many years? And now use your calculator. And remember, E is a number in your calculator, not the letter E, but the number E, and then this is in the exponent. All right, last one, and then the next sheet is your homework sheet for you to practice. Carla is investing $1,500 in a new 30-year retirement account. Determine which of the interest rates and compounding periods shown to the left would be her best investment option. So option A is 5.5% compounded what? Monthly. What's the other one? 2.7%, but it's compounded continuously. So you can tell that one has a better interest rate. Now, when you're investing, a better interest rate is the one with the bigger number. Did you listen to me? When you're investing, you want the interest rate with the bigger number. If you're taking out a loan, what's the better interest rate? The one with the lower number, right? So one has a better interest rate, but the other one is being compounded more often. So let's see which one is the better one by calculating both of them. So for option A, can you calculate it? And then for option B, can you calculate it? And then compare which one is the better option. And obviously the better option is the one that ends up with more money in her retirement account. when you're ready, look at the screen. Did you do option A correctly? Did you type it in correctly? So when it's compounded monthly, did you use the correct formula? Did you use monthly means 12 times a year? Now option B, can you calculate that? For option B, it's compounded continuously, so it's a different formula. Both start with 1,500. This one's going to be times E, and the exponent is going to be 0.055 times 30. Not 0.055. What's the interest rate? 0.027. So a different interest rate. So 0.027 times 30. Now, it's dramatically different, isn't it? So, which is the better option that she should use? Option A or option B? All right, so today's lesson was on compounding interest. And I think you found that as long as you know the formula, it's actually a pretty simple process, and then use your calculator. So, Mr. D Math, over and